If you're building iOS apps, at least one of these 5 bugs is in your project right now. Not maybe, probably. And here's the thing, nobody tells you when you're starting out. Eventually, a tech lead or a client is going to ask you about mobile security. They'll drop terms like MASVS or OWASP, and if you've never heard them, that moment is uncomfortable. In this video, we're fixing the 5 most common iOS security bugs with real Swift code, and I'm giving you just enough context on those standards so you can lead that conversation. I'm CodeHero. 18 years in the game, let's get into it. MASVS stands for Mobile Application Security Testing. It's the practice of analyzing binaries and runtime behavior for vulnerabilities that traditional web tools just can't see. These tools understand mobile-specific layers, like IPA files and platform-specific APIs that are fundamentally different from web architecture. OWASP is the nonprofit that defines the industry standards. Their MASVS document tells you what a secure app must do, while the MASTG guide tells engineers exactly how to test for it. You don't need to memorize these, but you should know that the 5 bugs we're about to fix are exactly what a MAST assessment looks for. Now, let's fix your code. Bug 1. Saving secrets in UserDefaults. You finish your login screen, the API returns a token, and you save it. Simple, right? Wrong. UserDefaults is just a plain text file in your app sandbox. It's readable from any backup and can be extracted in seconds. In OWASP terms, this is a MASVS Storage 1 violation. The fix? The keychain. It's encrypted and hardware-backed. The keychain ensures data is only accessible when the device is unlocked and prevents it from ever being part of a backup. This is how you stay compliant. Pro tip? Paste your files into the AI agent and ask it to flag every value in UserDefaults that looks like a credential. It'll find them instantly and generate the keychain replacement code for you. Bug 2. Killing HTTPS for the entire app. Your API fails in the simulator, you search for the fix, and you add a global exception to your Info.plist. It works, so you ship it, but you just killed your app's security. This disables TLS for every connection your app makes. Every API, every SDK, completely unprotected. This is a massive MASVS Network 1 failure that MAST tools will flag immediately. The fix is simple. Keep global enforcement on and only open a scoped exception for the specific legacy domain that needs it. 10 seconds of work to save your network security. Ask the AI agent to audit your plist for global ATS exceptions. It'll rewrite the block to be scoped and secure in a single prompt. Bug 3. Your app switcher is leaking data. When you hit the home button, iOS takes a screenshot. If your screen shows a balance or a password, that image is stored in plain text on the device. Forever. A MAST tester on a jailbroken device can pull that screenshot folder and read everything. OWASP calls this MASVS Platform 3. In Swift UI, the fix is just one modifier, redacted, paired with the scene phase environment variable. This modifier automatically replaces sensitive content with shapes whenever the app leaves the foreground. It's clean, professional, and protects your users' most private data. Ask the AI agent to review your Swift UI views for any text or image elements displaying sensitive data without redaction. It's an easy win for your security posture. Bug 4. Using algorithms from 1996. You need a hash, you search online, and you find MD5. But MD5 has been cryptographically broken for decades. Collisions can be computed in milliseconds now. This is a MASVS Crypto 1 violation. Don't trust AI prompts that give you MD5 code without a warning. Apple gives you CryptoKit for a reason. It makes secure choices the only choices. Use SHA-256 for hashing and AES-GCM for encryption. It's modern, hardware optimized, and tells you immediately if data has been tampered with. This is the gold standard. Ask the AI agent to audit your files for unsafe algorithms like MD5 or SHA-1. It will replace them with modern CryptoKit equivalents and explain why the old ones were dangerous. Never ship crypto you haven't reviewed. Bug 5, the one that costs you real money. You check for a premium entitlement, the network call fails, and your catch block fails open by granting access. An attacker with a simple proxy tool can trigger this in seconds. MASVS Auth 1 is clear. Authorization decisions belong on the server, not the client. Your catch block shouldn't be making business decisions. The fix? One word: false. Always deny access if you can't verify the entitlement. Log the anomaly so your team can see the patterns. Show the user a connection error, but never, ever give the product away as a fallback. Fail closed. Every time. Ask the AI agent to find every catch block that returns true or grants access on error. You'll likely find this pattern in more than one place. Fix it once, fix it everywhere. 5 bugs, 5 fixes, tokens in keychain, scoped ATS, scene phase redaction, crypto kit only, and fail closed entitlements. These map directly to MASVS controls. Keep this list handy for your next interview or client review. Remember, MAST is how they test your binary, and OWASP is the standard they test against. You don't need to be a security pro. You just need to know these tests exist and remove the bugs before anyone runs them. Subscribe for more on architecture, security, and using AI like agentic coding the right way. Run those audit prompts tonight and drop a comment telling me which bug you found. I'll see you in the next one.